these and doing factoring, just reminders, and you can jot down sometime if you're still having issues, or like I said, if you went into the YouTube page and just typed in factoring, I think there's another place on there where this actually has gone over again in more detail. But if there's anything in common, you always want to pull that out first, because a lot of times that's going to make the problem easier, or possible in some cases, to factor. And then basically we just break it down to, are there two terms there, or are there three? If there are two, is it a difference of squares? Ooh, I need to know my squares. Yes, I've been hammering at this for like months. You need to know your basic squares, at least up to 10. And then difference of cubes, again, has that pattern that's involved that we've talked about. And we're going to get to talk about it a little bit again today. If there's three terms and there's nothing in front of my x squared, it's a coefficient of 1, just do it like you do a diamond. If it's greater than 1, some of you have found slide and divide to be easier, some of you still do the mental math with it. And again, either of those things are fine to use. But it's not one of those that you can just throw your hands up and say, yeah, I don't get any of this, I don't know. You've got to kind of play. So like for instance, I look at this first one, I go, okay, nothing in common. Three terms, there's nothing in front of my b squared. So basically all I'm trying to do here is remind myself I got to multiply to get the numbers on the end. I got to add to get the numbers in the middle when I'm dealing with it like I would a diamond. And there's always clues there. And that's why when we get going so fast and we don't pay any attention, I'm kind of like, eh. Because on a problem like this, I go, okay, multiply to get a negative number. I know one's positive and one's negative. Add to get a positive number, which means the positive number has to be bigger. There's just some common sense and logic things to help you. Not a lot of choices on this. It's 5 and 1. If the bigger number's got to be positive, I put it there. I'm done. I keep life simple. Now, will they all go quite that lickety-split? No. But again, just looking for some of those patterns makes life a lot easier. I look at the second one. Nothing in common, but there's only two terms. What do you notice about both of these terms? Not cubes, but I appreciate that. Squares. So I look and I say, okay, whenever I'm dealing with squares in general, the form I'm going to be looking for is 1 plus and 1 minus to whatever I square to get it. What do I square to get x squared? X. What do I square to get 9? 3. And one's plus and one's minus, and I'm done. But again, I've got to understand my forms of these things. So with squares, that's always going to be the case. It's the same case that I'd have going on in 4. Two terms. The 2 being there is kind of a good clue. 3 is typically going to be cubes, but 2 is going to be squares. So what's this one going to end up looking like? Right, because 8 squared is 64, so it's plus 8 minus 8. I'm done. Don't make life more complicated than you need to with these. Now, sometimes is it going to get complicated? Yeah, it can. I'm going to go past my other diamond there at 3. I want to get down to some meaty problems here. Get down here, I'm like, ooh. 3x squared plus 23x plus 40. Nothing goes into all of those. Yuck. There's a number in front of x squared. Okay. There's a couple of ways I can tackle this. Now, this first one, I'll tackle it both ways. I'm not going to do this on every one. A lot of you in this case, automatically, which is fine, would head straight for a slide and divide type thing. Now, those of you that are new to me, you may never have seen this before. So here's an option for you. Slide and divide works where I slide that first coefficient down to the end and I multiply it. Because in this case, maybe I'd just rather deal with a diamond than I would something else. But you're like, not quite so sure about your diamond idea here, Harty, because 120? Really? Yeah, really. And if you're not sure on what multiplies to 120, basically at this point, some of you are going to have to go to the calculator and guess and check this for a while. It may not be the most fun thing to do, but as you play with these more, it might improve some of your multiplication skills so it gets a little bit easier. I mean, we all know the simple ones, like 120 and 1, but that doesn't work. 60 and 2, that doesn't work. And I'm just doing this. I would take the value I'm working with and keep just punching in divide by numbers until I find something that's going to work. Now I'm noticing I'm getting closer to 23 here. I'm like, I wonder if I get up to 5 if I'm going to be close enough yet. Oops, I don't want this to an exponent. That would not help me. I'm like, nope, not there yet. 6. Well, crap, Harty. How long am I going to have to keep doing this until I get to the answer? Now, I know off the top of my head 7 doesn't work. It's a decimal. But again, it kind of reinforces the process of working through these. 15 plus 8 is 23. Now, here's the thing though with slide and divide that some of you tend to forget. It's not called slide. It's slide and divide. Because I have some people that'll get here and they'll quit. And I'll go, but that's not, this does not multiply to this. X times x is not 3x squared. We have to use a little common sense. So if you're going to use slide and divide, you've got to remember the divide part is to take that coefficient and divide it back through. 15 divided by 3 is 5. 8/3 doesn't reduce, so it just swings back to the front. And we're factored. Now some of you were done with this problem 3 minutes ago because you just played the mental math game and kept doing it until it foiled correctly. Is that a better way in the long term? Yeah, but if you struggle with the mental math with that, this way works. I just like to kind of put that out there. For instance, as far as the mental math goes, I'm going to try that on 6. 3 doesn't divide into all of these. So I look at it, and if I'm going to play the mental math game, and I'd have a pencil probably ready for this, 3, I don't have a choice. It's 3 and 1, so it's 3n and n. The 45, though, I do have choices, though. Could be 45 and 1. Could be 9 and 5. It could be 15 and 3. And I have to play with this a little bit. Now, I'm pretty sure it's not 45 and 1 because, well, 45 and 3, that doesn't get me to 32. 135, if I multiply here and 1 doesn't do it, so no. And then I go, okay, 3 times 9 is 27. 27 and 5. Ooh, 27 and 5. Yes. The 3 needs to go with the 9. The 5 needs to go with the 1. 27 plus 5 is 32. Good. Could I slide and divide? Sure. I can go through that process. It still works. But again, sometimes just looking at some of the mental math that you could do to make it work might be better for some of you. And you might actually find out you like it better once you give it a chance for a little bit. Especially if the numbers are smaller, it might go faster for you to do that. You get a problem like 10. Now that gets a little more crazy because now it could be 9 and 1, it could be 3 and 3. But it's something that you've just got to keep playing with. I can keep talking and talking. I could do this for 5 days in a row and keep doing them all. You might think it's easy when you're looking at me doing it, but it's not quite so easy when you're having to do it on your own. Now, let me do one other thing here. I'm going to flip over to the back. Because I haven't had to use the golden rule once yet. Well, that's about to change. When I get to 13 on the back, something is divisible into both of these. Any takers for throwing a number at me that's divisible into both of those? Oh, dang it, we got the big one right away. I was hoping for a smaller one. Because here was the thing that I was going to mention. Is there anything besides 54 that goes into both of those? Not as far as numbers go. a k. But for those numbers that just got thrown my way, I'm going to talk about those here in a minute. So when I have something that's in common, it can be a number, it can be a variable, it may be both. If it's both, whatever I have left over goes in the parentheses. I already got the 54, I don't need that. I've got k, I need to get to k squared, so I need one more k. To get from 54 to 540, if you're not sure, again, just divide it in. 540, how many times 54 going in? 10, okay. And I already have the k, so I don't need another one. That's all I can do. But now that some of you started throwing other numbers at me, let me play with one of those for a minute. Let's say I looked at that and I said, okay, 9. Oh, yeah. Let's say I did 9 on this one. And I even remembered the k. So I went and I started working and I found, okay, so 9 times 6 is 54. And 9 times 60. And then I'd leave it like that. That's going to be an issue for me, especially when we start trying to look for things that are similar that cancel. Because here I'd look back at this again and I'd say, oops, I can take 6 out of each of these. So if I can do that, and I'm just going to show it this way once. I don't want you to be thinking of it this way every time. But if I took the 6 out, I'd multiply what's left out here. 9 times 6 would be 54k. And I can get to the same thing, but isn't it a lot better if I really try to make sure I get the biggest one? If I don't, I can do it this way, but I can never be content with this. You've always got to double check in your parentheses to make sure. Is there something else I can take out? Am I sure? And if I'm not, then I got to work that through a little bit more. Okay? So you've got to constantly be questioning things to make sure that things are going all right. If they're two-termers, even if nothing goes into both. Actually, let me do 17 here. Ooh, there's the clue. It's a cube. Okay. Cubics are special because they have their own little formula. What do I cube to get each of these? If you don't know, here's the next little hint. Because a lot of you don't have a cubed root button. What if I want to know what the cubed root is? Do I have to just start punching in numbers? I could. Or the other thing I can do is if I'm looking for a cubed root, I can take something to the 1/3 power, just like I could do 1/2 if it was a square root. I can get my value that way for what it is cubed. Or you could, like I said, you could just play with numbers because they'll be whole numbers. 5 cubed is 125, and I would need the a here. And the reason I do this and put this off to the side is when I go to do the pattern then, everything's going to be set up for me. Whatever I cube to get each of these, I just go ahead and write in the first set of parentheses, and I keep the sign, so I'm going to keep the plus. But then hopefully the pattern's going to get energized into your brains here when you start hearing it. I'm going to square the first term. I change the sign. I multiply my two cubic terms together here. So 6 times 5a is 30a. And then I square my last term, squaring the 5 and the a. And that's how my cubics work each time. So if it's plus, I start with plus, I go to minus. Well, what if it's not that? What if it's like 19? So what do I get to do then? The process is going to be the same. I still have got to figure out what I cubed to get the number. And for some of you, I might even suggest make yourself up a list of them so as you're working on them, you start to get in the habit of recognizing these. So 4x, will get me my first one. I'll put that in parentheses to remind myself for later. We just got done saying 125 is 5. So I go, okay, gotta know my pattern. Because just saying I don't like the pattern, it isn't going to help me. So I got my 4x, I got my 5. Whatever sign's in the middle is the sign I'm using. So this time it's minus. And again, the pattern goes, my first term, 4x, squared. So I'm squaring the 4, and I'm squaring the x. Bless you. The sign always changes. If I start with plus, then it turns into minus. It starts at minus, I turn into plus. I multiplied these two together. So 4x times 5 is 20x. And then I square my last term. 5 squared is 25. Nice thing about these, you'll never have to break anything down twice. As long as you get your cube or your square, it just sets up in a pattern and away you go. So, your job in this is going to be to take the factoring revisited sheet and work it through. Get yourself that practice so when we get into Monday, you're ready to fly into this with 2 feet. Okay? Some of you need to remember, you cannot afford to wait until when's the next homework check? I'll do it the day before. Nope. Because I think that's going to end up killing some of you on the test that you took yesterday. Because I could tell that's where the biggest struggle area was in 8-6, where I think some of you didn't have a homework check with it, and it made it kind of tough. So, like I said, I will have